Morning, girls. Really sorry we're not having a live lesson, but I genuinely feel horrendous. So I'm going to really quickly try and get through this without sneezing, which is the final part of P1. What we will try and do tomorrow is we'll go through a past paper, because we should be able to cover everything. I'll get you a better idea of what all the exam questions look like. I am going to send you some kind of trig Radian specific ones today, which again, hopefully you'll be able to work your way through now that we've finished all of the trig and Radian stuff. Obviously, feel free to do the exercise first to have a bit of practice of kind of the basics before you start trying to apply it to an exam question. If you don't understand the kind of, or you haven't practiced enough the basic stuff, then it's going to be difficult to put it into an exam question where it's a bit more complex. Right, so the last thing is area of a sector, which we find by using the formula half r squared theta, where r is the radius of the circle again, and theta is in radians. Now again, it's because the angle is in radians that makes this formula so much easier than when the angle was in degrees. A lot of cancelling happens with pi and stuff, leaving you with just a half r squared theta. So a really quick example, just using the formula on a real basic example. You've got a sector there. So remember, a sector is like a pizza slice. It's like you sliced up your circle, and you have a part of it. And we're trying to find the area of this sector, which has a radius of 2.44 and an angle of 1.4 radians. Remember, if there's no unit there and it's an angle, probably means it's radians. Okay, so we are going to put it into the formula, which should be nice and easy. So we're going to do a half times the radius squared, so 2.44 squared, multiplied by the angle, which is 1.4. Pop that into your calculator. Remember, at this point, it doesn't matter so much if your calculator's in radians, because we're just multiplying numbers together right now. But whenever you have sin, cos, or tan, that's when it's important that your calculator is in radians. So when I multiply all that together, I get my area is 4.17 if I round it to three significant figures. So it's 4.17. That's my area. That would be meters squared. Sorry, I'm sniffing. So that's obviously the most straightforward example that we could do, because obviously in an exam it's going to be a little bit more complicated than that. So this next example is taking it up another step. We have a plot of land in the shape of a sector of a circle. Always draw it out if you can, because it does make it easier to see what's going on. So we have something that looks like that. It has a radius of 55 meters. The length of fencing that is erected around the edge of the plot is 176. So we've been told the perimeter is 176 meters. Calculate the area. So right now we are missing the angle to be able to work this out. We're not given an angle at all. What we are given is a perimeter, and then we can use the formula from last lesson, the arc length formula, and kind of work it backwards to be able to work out the angle. So we know these two lengths are both 55, and we know the full perimeter is 176, so we can get the arc length from that. So the arc length would be 176 minus 55 twice, so that's minus 110, which is 66. I don't trust myself. It's still early, and 66 meters. That's the arc length. We know the formula for arc length is the radius times by the angle. So we know 66 is equal to 55 multiplied by theta. So divide 66 by 55 gives us 1.2 is equal to the angle. So now we know what the angle is. We can work out the the area of the sector. So we've used the information they gave us. They gave us the perimeter. From there we could find the arc length. From the arc length we can work the formula backwards to work out theta. Once we have theta, we can do the area, which is a half multiplied by 55 squared multiplied by 1.2, which gives us an area of 0.5, 55 squared, 1.2, 1,815 meters squared, because it's area. So that's your basic. I know that one's a little bit more complicated, but that's how we are working with sector area. We need the radius, we need the angle. If we don't have that, we need to do a little bit of working with other formulas that we know to work out a missing piece of information. Sometimes it might be using cosine rule or something to work out what the radius is. Sometimes it's like this and you're using the arc length backwards to find out what the angle is. But you'll find in an exam question you're always using 2 or 3 different things together to be able to work out what they're actually asking for. Now the last part is finding the area of a segment. Now a segment is something like this A part. So you've taken the sector and kind of joined up the 2 parts of the radius to make, I don't know, how would you describe that shape? It's not a pizza slice, is it? I don't know. To find the area of that, to really understand where the formula for this has come from, and you don't have to use the formula. You can do it kind of logically. So we would work out the area of the sector as we've done before using a half r squared theta, and then we would subtract the area of the triangle. So this part here is just a triangle, and we can work out the area of a triangle using the normal formula using a half AB sin theta. So this is the formula for the area of a triangle. I know I said a circle. The area of a triangle, which we looked at when we did trigonometry. It's just a basic trigonometric formula which works out the area of a non-right angled triangle where you don't know the base and the height. So half AB sin theta. Now again, because A and B in this type of question are both going to be radiuses, because we're looking at a circle, that becomes that AB becomes r squared. So that's where the r squared comes from. And we're subtracting those 2 things from each other. So the area of the sector, a half r squared theta, minus the area of the triangle, a half r squared sin theta. And if we do a little bit of rearranging and factorising there, we get this quite neat little formula, a half r squared theta minus sin theta inside the bracket. Now again, if you don't want to have to remember another formula, because there's a lot you have to know for P1, then it's just logic. It's common sense. You would work out the area of the full sector, subtract the area of the triangle, and that gives you the area of the segment. But again, if you want to remember the other formula, then that's what it is. A half r squared theta minus sin theta. So really quick example to use that. Here we have the radius is 7. We have the angle is 1.2 radians, and then we can put that into the formula. So the area of the segment is a half times by 7 squared multiplied by 1.2 minus sin 1.2. Now here is really important that your calculator is in radians, because we're putting our angle into sine, into a trigonometric function. So we need to do 0.5 multiplied by 7 squared, and then times by 1.2 minus sin 1.2. Remember, you're going to need a lot of brackets if you're popping that into your calculator all in one go. That gives us 6.57 if I round it to 3 significant figures. Now again, there's a lot we could do with these questions. You might have to use a bit of cosine rule to work out a missing length. You might have to find the angle first. There's a lot of extra bits they can put into this question to make it more challenging when you're looking at an exam question, but that's the basis of it. Make sure you can work with that first before you start trying to add other parts in. I'm going to stop this video there. I'm going to send you the exercise. I mean, I know you have it already, you have the textbook, but just in case, I'm going to send you the exercise that goes with this from that textbook, and I'm going to send you some exam questions based on this as well. I have to collect the exam questions first, so I'll send you the video, and obviously you've already watched the video, so you know you've got the video. I'll send you this and the exercise from the textbook first, and then I'll attach some exam questions later on for you to have a look at as well. But I hope this makes sense. Please feel free to send me any questions that you might have. Yeah, and I will hopefully see you guys tomorrow, if I'm feeling a bit better. Right, have a lovely day, girls. Thanks for watching and listening to the video. See you soon.